Are you staring down your Java exam, a little worried about I/O and applets? Well, you've come to the right place. In the next few minutes, we're going to slice through the noise and focus on exactly what you need to know to crush that test, starting with how Java moves data around. Okay, here's our game plan. We're kicking things off with the big idea behind Java I/O. Then, we'll get our hands dirty with the essential toolkit and some pretty cool advanced tricks. After that, we're switching gears to applets. The basics, their super important lifecycle, and how you can make them your own. Ready? Let's jump in.
All right, first things first, I/O streams. The best way to think about these is like the plumbing for your Java program. Seriously, they're just the pipes that carry data in from places like a file and then back out to somewhere like your screen.
Now, if there is one thing you need to get for your exam, it's this slide right here. It's super simple. Byte streams are for machines. They deal with raw data, pictures, program files, you name it. Character streams, they're for us humans. They handle text and take care of all the weirdness with different languages and symbols automatically. You nail this difference, you're in great shape.
So let's open up the toolkit. There are 4 classes you are absolutely going to use all the time for basic file stuff. Memorize these 4 and what they do, and you've just banked some easy points on the test.
First on the list, File Stream System. This is your tool for reading raw data. It just connects to a file and lets you start pulling in that data, one byte at a time. Simple as that. And its partner, of course, is File Output File Stream. This is for writing that raw data out to a file. But here's a big warning. By default, it just erases whatever was in the file and starts fresh. So if you want to add to the file instead of wiping it out, you have to tell it specifically. Okay, now let's talk text. When you're dealing with stuff you can actually read, you'll want to grab File Reader. It's way smarter than File Feast Input because it actually understands characters, not just a bunch of ones and zeros. And you guessed it, to write that text out, you use File Writer. So let's recap real quick. File Stream is for binary data. File Reader or Writer is for text. If you can keep those 4 straight, you've totally got the basics of file handling down. Listen up, because this is a pro tip that'll save you a world of pain. You have to close your streams when you're done. Leaving one open is like leaving the faucet running. It wastes system resources and can cause all sorts of bizarre errors. The absolute best way to do it is to put your close method inside of finally block. That way, you know it's going to run, even if your program crashes and burns. Okay, the fundamentals are covered. Now let's level up. We're going to look at some more powerful tools for when you need to do things that are a little more complex, maybe a little more efficient. Random access file is a total game changer. See, most streams make you read a file from the beginning to the end, like a novel. But random access file is like having a bookmark. You can use its seek function to jump to any point in the file instantly to either read or write. It's incredibly powerful, especially for things that feel like a database. Now these guys, these wrapper classes, think of them like getting a power-up in a video game. You wrap them around your basic streams to give them new abilities. Buffered Reader and Buffered Writer are all about speed. They read and write in big chunks, which is way faster. Data in-stream and out-stream are awesome because they let you work directly with Java's basic data types like integers and booleans. And finally, object in-stream and out-stream. These do something that feels like magic. It's called serialization. You can take a whole object, squish it down into bytes, save it, and then bring it back to life later. So cool. All right, let's totally switch gears and talk about Java applets. And I know what you're thinking. Wait, aren't applets like super old? And yeah, they are. But here's why they're still in your exam. The ideas behind them, especially their life cycle, are the building blocks for basically all modern user interfaces. So understanding them is still super important. So what is an applet, really? It's just a little baby Java program that doesn't run on its own. It's designed to live inside a web browser, embedded right into an HTML page. It's basically a guest in the browser's house. And this slide right here perfectly breaks down the key differences. A normal Java application has a main method. It's the boss, and it has full access to your computer. An applet, though, no main method. The browser is in charge. And for security reasons, it's forced to play in a sandbox. Think of it like a kid's playpen. It can't get out and touch your files or do anything dangerous. Okay, this is the absolute core of applet programming, the life cycle. It's a sequence of 5 methods that get called in a very specific order, and I can almost guarantee you're going to get a question about this. So let's walk through it. So here it is. First, a init is called just one time when the applet is born. It's for setup. Then start is called to get it running. After that, paint is called anytime the screen needs to be drawn.
If you navigate to another web page, stop gets called to pause things. And finally, when you close the browser tab for good, destroy is called to clean up. The order is always init, start, paint, stop, destroy. Get that sequence down cold.
All right, so knowing the life cycle is great, but how do we actually make an applet do something? Draw stuff, show text, be interactive. Let's take a look. That paint method is basically your canvas, and when it gets called, the browser hands you this magical tool, a graphics object that we usually just call G. Using G, you can do pretty much anything visual, draw text, draw shapes, change colors. All the visual action happens inside the paint method. And this is a really neat trick for making your applets more flexible. You can actually feed information from the HTML file right into your Java code. You use this thing called a param tag in the HTML, and then inside your applets code, you just call getParameter to grab that value. It's awesome because it means you can change how the applet works without having to recompile your Java code every time. So, as we wrap up, here's something to think about. We've talked about two big ideas, managing the flow of data with I/O streams and managing the flow of user interaction with applets. In the software we build today, which one of those is more fundamental? Is it what's happening with the data under the hood, or is it the user's experience on the screen? There's no right answer, but it's a cool question. All right, that's it for this one. Good luck on your exams.